We're going to look at harder examples of sines and cosine functions and how you want to complete a full graph. So first of all, we'll look at y equals 2 sine 3x, and what each number does to the graph. The number 2 is the amplitude. In order to figure out what the period is, we take the normal period for a sine function, which is 2 pi, divide it by 3, and that's the period, 2 pi over 3. You can think of that in two ways. If this is 120 degrees, you could say that it completes one full cycle in 120 degrees, or you could say that it completes 3 cycles in the same amount of time the regular sine function would complete one cycle. The frequency is the reciprocal of period, 3 over 2 pi. This has no vertical shift, this has no phase shift. Now, back a long time ago, when we were graphing parabolas, you had to give the x-intercept, the y-intercept, the zeros of the function, sometimes the maximums and minimums. This list over on the right-hand side of the slide is the information you need to give when you're graphing a sine, cosine, or tangent function, or one of their reciprocals. So I'm going to start this graph off with a small sketch of the normal sine function. The normal sine function goes at 90 degrees, it's 1. Let me make one a little bit shorter here. At 90 degrees, it's 1. At 180 degrees, it's 0. At 270 degrees, it's -1. And at 360 degrees, it's back to 0. So there's your normal sine function. This function is going to have twice the amplitude and is going to complete that full cycle 3 times in 360 degrees. The first thing I need to do is figure out my units. Right here is 180 degrees, or pi, and right here is 2 pi, and I need to divide that into 3 equal pieces. So if you have trouble with working with fractions, you might consider taking the period, which is 2 pi over 3, and multiplying it by 180 divided by pi. The pi's cancel. That's 360 divided by 3, that's 120. And so the increments for this graph are going to be 120, plus another 120 is 240, plus another 120 is 360. It's sort of like, there's my 360 mark. I'm dividing this into thirds. 120 is 30 past 90. 240 is 30 shy of 270. And then in each of these thirds, I have to have my 5 points. Another way of looking at it is, if your normal sine function goes from 0 to 2 pi for everything that happens, this function is going to go from 0, oh, it's hard to hit that, 0 to 2 pi over 3. And so half of that is going to be 1 pi over 3. That's 60 degrees. And half of that is going to be pi over 6. So that's 30 degrees. So this function is going to go hit 1 at 30 degrees. At 60 degrees, it's going to be 0. At 90 degrees, it's going to be -1. Except for, we forgot about the amplitude of 2. So let's throw the amplitude of 2 in there. It's going to go 2 high, back down to 0, 2 low. It's going to go up, down, and back, and do a full cycle in that 120 degree section. And if I divide this next section into 4 equal pieces, it's going to do the same thing. Up, down. Let's try that again. I'll just draw over it. Up, down, and back in 2 pi over 3. And then one more time, divide that into 4 sections. Up, down, and back. And so this, if you're looking at this graph, and we're counting along it, it does 1, 2, 3, full cycles in the 360 degrees, and that's what this 3 here is. It tells you how many cycles it's going to do in a normal period. This is an example of basic phase shift. This function has an amplitude of 1, it has a period of 2 pi, has a frequency of 1 over 2 pi. Remember, period and frequency are reciprocals. No vertical shift. And this phase shift is going to be the right pi over 2. So the way I graph this is I start off graphing the normal sine function. The normal sine function goes from 0 up to 1 at 90 degrees, back down to 0 at 180 degrees. At 270 degrees, it's down to -1. And at 360 degrees, it's back to where it started. There's your normal sine function, -1 to +1. So I'm going to take every point on this graph and shift it to the right 90 degrees. So this point is going to move here to 90 to this spot. And this point that's at 1 is going to shift 90 to the right. It's going to move to here. This point that's at 180 is going to shift 90 to the right. It's going to be here. This point at -1 is going to shift 90 to the right. It's going to be here. And after I get all the points shifted to the right, I can fill in the function. It looks like this. And they'll start asking you questions about like how this graph compares to another graph you might know. And some of you guys might recognize that this is the same as if I were to do the cosine graph flipped upside down. After spring break, we're going to be solving equations and doing identities with sine and cosine functions. And recognize these relationships will help you score better and understand things better when we get to back after spring break. Now we're going to look at a harder example of phase shift. And you might look at this and think, oh, it's just shifted to the right pi. But you cannot tell what the phase shift is if there's a number in front of the x. So if there's a number in front of the x right there, that 2, we can't tell what the phase shift is. In order to tell what the phase shift is, we have to factor out the 2. So we're going to rewrite this function as y equals sine of 2 parentheses x minus pi over 2. Now we can evaluate this function, and this phase shift is going to be to the right 90 degrees. Amplitude is 1. Period is 2 pi divided by 2, or pi. Frequency is 1 over pi. No vertical shift. This has a phase shift that goes to the right 90. I'm going to start off with my base graph. My base graph for this graph, here I'll go 90, 180, 270, 360. There's my normal sine function. And my normal sine function would go up to 1, back down to -1, look like this. Okay. This function is different because it has a period of pi. So it's we're going to take and put a mark where pi is, and then divide that into 4 equal pieces. I'm going to do it on both sides. So this is going to go up, back to 0, down to -1 and back, twice, and the same time the normal one did it once. So the red graph I have right now is a sine function with a period of pi, but now I have to add in a phase shift. So with phase shifting, you're going to take each point, here's the point 0, and I'm going to move it to the right 90. So this point is going to get moved to here. I'm going to take this point and I'm going to move it to the right 90. So it's going to get moved over here. This point is getting moved to the right 90. So it's going to get moved over here. I'm just going to take every point on the graph and scoot it to the right 90 degrees. And if you think of 90 degrees, like if you're looking on this graph, this is 180 degrees. So 90 degrees is basically 2 hash marks. So everything is going 2 hash marks to the right. 2 hash marks, 2 hash marks, 2 hash marks. It should be here. This one's here. This one's 2 hash marks there. This bottom one's 2 hash marks here. So this graph is going to go up, down, back, over, down, and this last point is going to be right here. So I don't have a really light dotted line on this, but what I would do if I were you is make the green graph sort of in a dashed pencil, and then make the red graph with a really light dashed pencil. And then your actual solution is this graph right here. We haven't looked at a phase shift yet, so let's take a look at a graph with a phase shift. I'd like to graph y equals 3 sine x minus 2. Okay, the normal 3 sine x graph has an amplitude of 3 and a period of 2 pi and a frequency of 1 over 2 pi. So I'm going to start off with my 4 hash marks, and I'm going to go up to 3, back down to 0, back down to negative 3 at 270 degrees, and back up to 1. So there's my sine function. This new sine function is the same, it's just shifted down 3. So I'm going to think about where my axis is, and I'm going to move it down, sorry, it's going to be shifted down 2. I'm going to move all of my points down 2. And so this point here is going to move to here, down 2, each point moving down 2. And the reciprocal function, not the reciprocal, sorry, the vertical shift function shifted down 2 looks like that. I want to do a super easy example right now, because I know sometimes you get to take a quiz and you've learned all of this new stuff and you forget the basics. So let's say you just had a basic function, like let's say you had y equals cosine of 1/2 x, and the problem wasn't knowing what to do with the 1/2. The problem was you just didn't have a clue what the cosine function looked like because you forgot. If that happens to you, you need to fall back to, if you have a triangle and the radius is 1 right here, here's the y value, here's the x value, cosine is adjacent over hypotenuse, so in the unit circle the cosine is the x value. And if you were to think about all of the points on the unit circle, 1, 0, 0, 1, negative 1, 0, and 0, negative 1, you could work your way around this graph, and let me do it really lightly up here. So a cosine function at 0 degrees, it should be 1. I'm looking right here, the cosine function at 90 degrees should be 0. So at 90 degrees, you should be 0. Then you look right here, the cosine function at 180 degrees is negative 1. Oh, that's supposed to be a dot. And then the cosine function, and now you're looking right here at 270 degrees, it's back down to 0. And then you're looking right here, the cosine function at 360 degrees is back to 1. So if you're going to graph that cosine function, I'm going to graph it really lightly, it looks like this. There's your cosine function. So now let's take a look at what happens to the cosine function if the period changes. This function has an amplitude of 1. It has a period of 2 pi divided by 1/2. That's 4 pi, or a frequency of 1 over 4 pi. No phase shift, no vertical shift. So my period got twice as long, which means I'm going to need more room here. See if I can make myself some more room. So there's my cosine graph. and this point right here is 2 pi. I want it to go all the way out to 4 pi. So the first thing I'm going to do is extend my graph. So 2 pi, double that, here's 4 pi. And if I think about this, like let's say with a table of values, my normal cosine function is going to go from 0 to 2 pi. This is going to be pi, this is going to be 90 and 270. And it's going to go 1, 0, negative 1, 0, 1. My new function is going to do those same numbers, but it's going to do it from 0 to 4 pi. And so this is going to be 2 pi, and this is going to be pi, and this is going to be 3 pi. So at 0, it's going to be 1, just like the first graph. I'll do the second graph in red. At pi, it's 0. At 2 pi, it's negative 1. At 3 pi, it's 0. And at 4 pi, it's 1. So this function's period got stretched out. It looks like this. Okay. That's about 12 minutes worth of examples, so I'm going to cut it short. You will have some basic graphs on your quiz tomorrow as well. You should be prepared on the quiz to graph y equals sine of x, y equals cosine of x, y equals cosecant x, y equals tangent x, and also examples of changing amplitude, period, frequency, phase, and vertical shift for the basic functions, sine and cosine.